Project 2.9 Unpacked the 595 chip. The 74HC595 is a popular integrated circuit used to expand the number of digital outputs from a microcontroller. It takes in data serially, 1 bit at a time, and then outputs all 8 bits in parallel. This means you can control 8 LEDs or other outputs while only using 3 pins from something like an Arduino. Internally, it uses a combination of D flip-flops and latching mechanisms to shift in data and then output it cleanly. This project aims to unpack or break down the 74HC595 into simpler components like the D flip-flops. A shift register is a sequence of flip-flops connected in a line. Each flip-flop stores 1 bit of data and shifts it to the next one with each clock pulse. This project emulates a serial in, parallel out shift register, meaning that input data is inputted 1 bit at a time, and once it moves through the flip-flops, it becomes available across multiple output pins all at once. This is a powerful way to control many outputs using very few inputs. At the heart of this circuit are D-type flip-flops. These devices take in a data value and store it on the rising edge of the clock signal. The value stays stable even if the input changes until the next clock pulse. This precise timing is what allows data to move step by step through the system. For this project, the clear pin was used to reset all flip-flops instantly when needed. To create clean and consistent clock pulses, the 555 timer was used in monostable mode. When triggered, it sends out a timed high pulse. This pulse becomes a clock signal that shifts data through the flip-flops. Every press of the clock button sends 1 pulse, moving the data one step forward. To separate data movement from output, a second set of flip-flops was added for latching. These only update when the latch button is pressed, ensuring that the output LEDs do not flicker during data shifts. This mimics how the 74HC595 keeps its output stable until the latch signal is received. This interface is fully manual using 4 buttons. The data button, which sets the input bit to either 1 or 0. The clock button, which triggers the 555 timer to shift data. The latch button, which updates the outputs. And the clear button, which resets everything. This setup lets you see each step of the data movement process, making the internal operation of the S74HC595 chip visible and easy to understand. The goal of this project was to build a functional, hands-on version of a shift register using flip-flops. It's a great way to learn how binary data moves through digital circuits and how control signals like clock and latch help coordinate that movement.